Satellite internet has been around for more than 2 decades now, but it's never been popular with users that need high-speed internet. But technology has advanced incredibly fast in the last 20 years. So why doesn't everyone have super-fast satellite internet by now? It's a new era in the space race, and SpaceX's Elon Musk wants to provide fast and stable satellite internet access to the 4 corners of the planet. But China has already begun putting its own satellite constellation into space that provides lightning-fast 5G. Who will win this new space race? Is satellite internet about to overtake hardwired connections in speed and stability and replace them altogether? Get ready to discover why satellite internet won't just be an option, it might just become the future of high-speed internet that everyone in the world will want and have access to. When you hear the name Elon Musk, probably brings to mind his electric car company, Tesla, or his impressive SpaceX that designs and builds advanced rockets and spacecraft. But you've surely heard of Elon Musk's relatively new venture called Starlink, which is causing quite a stir in the tech world. The goal of Starlink is to provide a fast internet connection to anyone on the planet, regardless of where they live, by utilizing a growing network of private satellites floating around what's called low Earth orbit, or LEO, just about 550 kilometers over our heads. We said relatively new because Musk and the SpaceX team have been working on bringing Starlink internet to the world since 2015. While Starlink is the shiny new thing, let's not forget that satellite internet itself isn't new. Services by early internet providers never caught on simply because the speed and connection wasn't stable or fast enough for gamers or streamers. Some people in the most remote locations would have no other choice but to use it because they had no hard lines or physical wide connection available. The way satellite internet is set up and understanding satellite internet speeds are important things. The standard unit of measurement for data transfer speed is 1 bit is an eighth of a byte. Data speeds can be measured in kilobytes or megabits per second. 1 megabit per second equals 1024 kilobits per second. The more megabits, the faster online speed is. Downstream bandwidth is the maximum rate at which data can be received over an internet connection, and the maximum rate at which data can be sent is called upstream bandwidth. Currently, 2 of the largest major satellite internet providers are Viasat and HughesNet. In 1993, the Hughes Aircraft Company applied for an FCC license to use Ka-band frequencies on the electromagnetic spectrum. In satellite communications, the Ka-band allows higher bandwidth communication. Hughes then filed for a license with the FCC to develop Spaceway, the first Ka-band satellite, which was launched by Hughes Network Systems Inc. in 2005. After the successful launch of Spaceway, the FCC put out a call for more companies to get involved in satellite internet service. Viasat has 4 of these big satellites in geostationary orbit. They are big satellites, with Viasat-2 weighing 6,417 kilograms. It has a wingspan of 158 feet, including its solar arrays, which generate 8 kilowatts, 23 miles of electrical wiring, and offers a total data throughput of 300 gigabits per second. However, a wiring problem somehow lowered that down to 260 gigabits per second. Of course, that speed is divided up amongst the users in smaller portions and the data is capped. How you get that signal to your computer works by mounting an antenna outside of a business or home, maybe on the roof of a building, for example. Then a hard line runs from the antenna into the home that attaches to a wireless router, which all your devices connect to. And this is how it works. Let's say you're using HughesNet satellite service. You want to browse the internet or play games online. A request is sent from your computer to the satellite. The satellite contacts the HughesNet Network Operations Center, better known as NOC, which in turn contacts the target computer, which then beams back the information you want on the same path to your computer that the request came from. That's quite a journey for data to travel back and forth. Now, all of this sounds good, but both Viasat and HughesNet satellites operate in geostationary orbit over the equator at around 37,014 kilometers above the surface of the Earth. This is where something important called latency comes into play. Latency can be explained by clicking the play button on a YouTube video. It takes an average of 100 milliseconds for the data to travel back and forth from the satellite to your computer. Many using current satellite services will tell you it's more like 300 to 600 milliseconds or 0.6 seconds. A half a second of delay in anything online would be unbearable for most users, such as watching a movie with a half-second out-of-sync audio track, or more than a half-second online delay in a game where every half-second counts. However, geostationary satellites aren't down for the count and have some advantages over low Earth orbit satellites. For one, they can be pointed at a particular place on the ground to cover an area that needs access. The higher orbit means a greater field of vision, and the satellite can cover up to 1/3 of the globe, which would offer more stability, since LEO satellites spend a lot of time over oceans and unpopulated areas and are not always able to monetize their signal. These newer big satellites can shift capacity from areas of lower need to areas that need more bandwidth. These things sound great, but there are two things that are a problem for this type of geostationary orbit communication satellite. The distance that the data has to travel back and forth from the satellite is one, but the other is that it's just one large satellite handling everyone's data at the same time. So how does Starlink measure up to this type of internet? And how is it going to revolutionize satellite internet? First of all, Starlink satellites aren't as big as the geostationary models. These units are the size of a small table. Secondly, Starlink satellites will be somewhat between 200 to 400 miles above the planet in low Earth orbit. That's much closer than traditional satellites, which allows for a much lower latency. But because of the lower orbit, there needs to be a lot more satellites. Currently, there are 1,469 Starlink satellites in low Earth orbit, but there are 42,000 planned, which will make up a mega constellation, with the plan being to offer high-speed and low-latency internet access with an advertised speed of up to 500 megabits per second and latency as low as 20 milliseconds. In February 2021, SpaceX announced they had over 10,000 users. SpaceX has been trying to get as many satellites into low Earth orbit as quickly as they can. But things haven't always gone as planned for SpaceX and Starlink. On March the 8th, 2022, SpaceX announced that 40 of 49 satellites would not make it to their final destination, and instead of reaching low Earth orbit, they would enter the atmosphere and burn up. So what happened to cause this major malfunction? According to SpaceX, the latest batch of launched satellites got caught in a geomagnetic storm, causing the Earth's atmosphere to warm and increase in density. This resulted in a 50% higher than normal atmospheric drag, which pulled the satellites back to Earth. A few of the Starlink satellites, like this one, were captured entering the atmosphere and disintegrating in a dramatic light show over the night skies of Puerto Rico. It was a disappointing setback for SpaceX's Starlink plans. However, Elon Musk and Starlink didn't let this slow them down. It wasn't long after the war with Russia started before Ukraine's Minister of Digital Transformation, Mikhailo Fedorov, reached out to Musk with a request for Starlink satellite internet service, to which Musk responded by sending thousands of terminals to Ukraine. In fact, in less than 48 hours, the first terminals started to arrive. This was a chance to not only help the country, but to test how the system would work in such a situation. Since then, reports say that Starlink is up and running and working as advertised. It turns out that Musk has been sending terminals to the war-torn country just about every other day, and thousands of users are taking advantage of the service. There are now over 5,000 plus Starlink terminals in the country. But with all this said, the technology is still in its infancy, and experts aren't quite sure of its safety and security. Some warn that Russia could figure out how to detect the signals and locate the terminals. However, for these same reasons, it might make the technology difficult for Russians to hack. Musk still sent out a warning that Starlink was the only non-Russian communications still working in some parts of Ukraine, and that its probability of being targeted was high. In fact, in February 2022, some Starlink terminals near conflict areas were jammed for hours at a time. A new software update fixed the problem, and Musk let everyone know that cyber defense is a big focus at Starlink. But what does the future hold for satellite internet? It'll be interesting to see if satellite internet will finally get a more positive reputation. Speeds and stability have definitely improved, and according to Nielsen's law of internet bandwidth, the speed of a high-end user's internet connection should grow by 50% each year. Since 1983, this has been accurate. Starlink claims that users can expect speeds of 150 to 500 megabits per second. The standard Starlink tier claims that users can expect speeds of between 100 and 200 megabits per second. That's fairly good, considering that the fixed broadband speed in the USA is around 136 megabits per second. The cost for Tier 1 Starlink is $549 for the hardware, a $99 deposit, and the service is $110 per month. Starlink also has a premium service that offers 150 to 500 megabits per second, but it has a much bigger cost for hardware at $2,500 plus a $500 deposit and $500 per month, and is likely intended for a business with many users. It's not cheap, but users in rural areas who have struggled with slow broadband say that Starlink's fast internet is worth the cost. There are already 2,000 of these table-sized satellites out there, and SpaceX plans to launch a total of 42,000 satellites into low Earth orbit. But it turns out that Starlink isn't the only game in town when it comes to this new generation of satellite service. China has their own answer to Starlink called Galaxy Space. On March 5, 2022, the Beijing startup watched 6 new satellites launch into space aboard China's Long March 2C rocket. The plan is to launch 13,000 of these satellites into low Earth orbit and build the world's leading broadband satellite constellation and offer global coverage with a 5G communication network. This connection could offer speeds of over 500 megabits per second and even 80 megabits per second in the worst weather. However, these are interesting claims, as there are no standards or implementation specs for 5G anywhere in space. On the ground, it's a different story, with China claiming to have around 730 million 5G subscribers. That's over half the total population. But Starlink has some tricks up their sleeves when it comes to reducing latency by incorporating built-in lasers on the latest Starlink satellites that can transmit data between each other in orbit. Starlink says that lasers can help the satellites transfer hundreds of gigabytes of data, and that laser links in orbit can reduce long-distance latency by as much as 50% due to higher speed of light in a vacuum, and having a shorter path than undersea fiber cables. This means that it could be possible for the Starlink satellites to serve internet data to users without even fetching the data from the ground stations on Earth. Once everything is said and done, this means launching a ton of satellites into orbit. With all these companies putting so many satellites into space, we have to wonder what kinds of problems this will cause for humans in space, and what problems there'll be on the ground. There are about 5,000 satellites in Earth's orbit. If SpaceX and Galaxy Space and several other new satellite companies start launching swarms of satellites into orbit, it could cause problems with ground-based astronomy and astronomers who have images contaminated with satellites. The other issue is that with so many satellites floating around in low Earth orbit, the potential for collision with another object greatly increases, which will just create more space junk hazards. We should also keep in mind that the International Space Station is in the same orbit, and there could be catastrophic collisions with the station. Two things that SpaceX is trying to do right now to fix these problems is by creating satellites with a non-reflective surface. There are 2 prototypes already tested, the DarkSat and VisorSat. As for the second problem, Musk says that each satellite is designed to deorbit within 5 years in case of failure. meaning it'll disintegrate by entering Earth's atmosphere. The collisions in space is another story. SpaceX's Starlink satellites have 1,600 close encounters between two spacecraft every week. And these encounters include situations when two spacecraft pass within a distance of 1 kilometer from each other. This means that satellite operators are going to be very busy. It's estimated that an operator managing about 50 satellites will probably receive up to 300 official alerts a week. These alerts will include encounters with other satellites as well as pieces of debris. Out of these 300 alerts, up to 10 might require operators to perform avoidance maneuvers. Right now, there are over 43 million people using satellite internet, and that's expected to grow to 110 million by 2029. As of March 2022, Starlink is available in 29 countries. More and more people will be using satellite internet very soon. We'd like to know what you think the future of satellite internet will be. Let us know what you'd like to see next, and make sure you stay tuned here for exciting new things happening in and around our world. Thanks for watching.